Assalamualaikum and hi, it's me again, Miss Huda. Let's continue with example number 7 for the gravity retaining wall design. The masonry dam whose cross-section is shown in the figure retains water against its vertical face. Examine the stability condition of the dam with respect to tension in the joints, ground bearing pressure, overturning and sliding. Given the unit weight of the retaining wall is 21.6 kilonewton per meter cube and angle of wall friction is 30 degrees delta. When we get a question to calculate on the stability condition, we must know that first thing we must find the weight of the wall and the lateral thrust that acting at the back of the wall. We can draw the pressure distribution for the lateral thrust at the back of the wall. This one represents water as the retained material. The pressure distribution for the water would be increased uniformly from the top until bottom of the water level. Since in the question it mentioned that the water level reached the top of the retaining wall, which means that setinggi-tinggi retaining wall ni lah water ni punya level ya. And then for the retaining wall itself, we need to calculate the weight, divide it into 2 here to make it easier for us untuk calculate the distance from centroid, because we need to find the stabilizing moment dan juga overturning moment. Just prepare a table like this. For the vertical force, get the level arm from A because we need to find the moment. Sebab kita tahu overturning moment adalah dekat A, which is dekat toe of the wall. The wall will overturn dekat toe. Vertical force maksudnya adalah weight of the wall. For the first section here, I name it as W1. We need to get the area first so that kita boleh darabkan dengan unit weight to get the weight of the wall. This is a triangle and overall width dia adalah 2.7 and kat sini adalah 0.9. So 2.7 minus 0.9, you will get 1.8 meter here. So the area of the triangle would be half times 1.8 and times width, the height 4.2 meter. So ini adalah area and we need to times with the unit weight of the wall, which is according to the question, it is 21.6 kilonewton per meter cube. So ini adalah area tadi dan kita darabkan dengan unit weight. Dia punya unit bila kita darabkan kilonewton per meter sebab kita tak darabkan dengan panjang retaining wall ni. Of course lah retaining wall ni sebenarnya memanjang ke sana kan. So per meter ni adalah reflecting this one for every meter of the wall length. For the first section, I get 81.648 as the weight and get the level arm from A. So meaning that the distance should be from the centroid of W1 to point A dekat toe which is the distance yang kita nak adalah L1. Untuk dapatkan moment, remember distance dia mestilah 90 darjah daripada the direction of the force. Therefore, this one adalah 2/3 daripada the breadth of the triangle tu. So 2/3 times 1.8 meter. That is the level arm. Then get the moment by multiplying the force with the lever arm, you will get the moment. Next, we're going to calculate for W2, which is, this is the rectangle. Rectangle, get the area, 0.9 times 4.2 meter. That is the area. And you need to times with the unit weight of the wall, 21.6 kilonewton per meter cube. Next, get the lever arm from A. From the centroid of W2 to point A. Is this 90 darjah distance daripada the direction of the force. So dari ini separuh, you have separuh daripada 0.9 and you have to plus lagi another 1.8 meter. You will get 2.25 and get the moment by multiplying 81.648 with 2.25. Get the total vertical force, tambahkan W1 dan W2 and get the total stabilizing moment by tambahkan moment W1 and moment W2. We have the horizontal force. Horizontal force, so kita tahu itu adalah force from the retained material. This is the triangle that shows the pressure distribution of the liquid at the back of the wall. And we know that the value here would be, because this is the water, unit weight of water times H, or if you use the density, it should be density of water times G and times H. So you boleh pakai yang mana-mana, doesn't matter, because in this question dia tak ada bagi any value untuk unit weight of water ataupun density of water. So kita dah ada formula dia sebenarnya daripada area of this pressure distribution. We know that it is half times unit weight of water H times lagi dengan H area-nya, or half times the density of water times gravity acceleration times H and another H. So you boleh pakai mana-mana, but I prefer pakai this one lah, because of tak perlu lagi darab dengan gravity acceleration. The things that kita mesti ingat, and this is fixed ya. The unit weight of water memang sentiasa 10 kilonewton per meter cube. Takkan berubah. And the density of water is 1000 kilogram per meter cube. Takkan berubah. So kalau soalan ni tak bagi, you boleh pakai mana-mana dan pilih the formula yang mana-mana you nak pakai. Dalam kes ini saya pakai unit weight ya. So kita masukkan ikut our formula tadi, which is half times the unit weight of water times with the H power of 2. Tadi H darab H kan, jadi H power of 2. Here I get 88.2 for the horizontal force. Next, kita akan kira level arm from A. From the centroid of the triangle of water ni, dia nak pergi ke A. So, distance dia should be 90 degrees ya, daripada direction of the force. Berapa panjang ini? So, ini adalah 1/3 times H. So 1/3 times 4.2 height of the water. Then you get the moment about A, multiplikan 88.2 with 1.4. In this question, there is no other horizontal forces acting at the back of the wall, only the water. So that is the only force yang kita ada arah horizontal. Total up kan, the total RH and the total overturning moment. Kita nak start kira the stability calculation. But before that, we need to find the value of X because kita nak tahu di mana position of the ground reaction. Using the formula B minus total stabilizing moment tolak total overturning moment divide with total RV. B, we have the base 2.7 meter. The base panjang dia minus with total stabilizing moment, this one, minuskan dengan total overturning moment, ini, and divide with total RV, 163.296. When you calculate, do this in a bracket first, baru you ambil 2.7 and minus everything. You will get 1.731 meter from B. Meaning, dari B di sini, it is 1.731 meter. That is the value of the position of the ground reaction. That is the distance of the position of the ground reaction. Kita nak tahulah, satu, dia minta kita check on the tension in a joint. So, kita dapat tengok sama ada tension in the joints or not using this value of X. So, the retaining wall is 2.7 meter, the base. Kalau kita bahagikan kepada 3 bahagian, starting from B, 0, 0.9, 1.8 and 2.7. And kita tengok the value of 1.731 meter from B ni berada di mana. It's still inside the middle third sebab dia adalah 1.731. Lebih besar dari 0.9 but less than 1.8 meter. Middle third lies between 0.9 and 1.8. The resultant force RV cuts inside the middle third. Hence, no tension will develop in the joint. So, kalau the cuts inside middle third, it means that there will be no tension in the joints. Kalau dia cuts outside ataupun dia di luar daripada middle third, meaning there will be tension in the joint. And bila kita dah dapatkan X, also kita dah tahu dia inside middle third, then we can calculate the ground bearing pressure. Formula yang kita ada options, which is one as here, ataupun the other one is QA equal to 2V divide with 3 bracket B minus X. Ini kalau outside middle third. Ini inside. So kalau case kita, it is inside. That's why I use this formula. V over B. So take the value of V, which is 163.296 divide with the base 2.7 meter. 6, this is RV again, times with the eccentricity. The eccentricity, you just take the B over 2 minus kan dengan X. So, B over 2 adalah 2.7 meter bahagi 2 tolak dengan 1.731. 2.7 meter bagi 2 equal to 1.35 meter minus 1.731 meter. You akan dapat jawapan dia value negatif 0.381 meter. Okay, tak perlu letak negatif ni ya. ignore it because this is distance. Distance negative tu tak ada makna ya. So you masukkan the eccentricity yang kita dah kira di sini and divide with the b square which is 2.7 square. Solvekan according to this and another one. For QA, it will be 60.48 kilonewton per meter square plus 51.206 kilonewton per meter square. While for QB, it will be 60.48 kilonewton per meter square minus 51.206 kilonewton per meter square. Then you akan dapat the value for QA and QB. So pressure distribution dia will look like this. This is B, this is A. The value at A is 111.686 kilonewton per meter square and the value at B is 9.274 kilonewton per meter square. So kita dah dapat the ground bearing pressure. And since this question tak ada bagi any value for you untuk compare, for example, the safe bearing capacity of the soil, then kita tak ada something to compare lah. Then leave it like this. The question also asks you to find the factor of safety against overturning. So we have the formula for this. Total stabilizing moment divided with total overturning moment. Just get the value from the table that kita dah kira di sini, which is total stabilizing moment and total overturning moment. You will get 2.281. That is factor of safety against overturning for this retaining wall. So kita tak ada anything to compare. Just leave the answer like this. Next, we're going to calculate the factor of safety against sliding. You have the formula for factor of safety against sliding. Mu RV divide with P. Mu RV ni asalnya daripada RS which is resistance to sliding. So ini adalah the formula. Mu is not given the question, however, dia bagi value of delta. From the question, we get the delta is 30 degrees, the angle of wall friction. Replace the delta with 30 degrees, we get the value of mu. Put it into the formula of Fs and get the RV from the table, 163.296, divide with horizontal forces. From the table again, get the RH, 88.2. Factor of safety against sliding is equal to 1.068, and since there is no factor of safety that you can compare, then leave the answer like this. That will be all for example number 7. See you in the next video. Bye.